So I hope to do a video on percent increase and percent decrease, and these are actually pretty interesting. And if time permits, I'm going to do percent error. So here's how it works. You're actually going to use the same formula, well, pretty much for both of them, but there's slight alteration, and it works like this. You take the big number, and you subtract the smaller number, and because we're increasing, you divide it by the smaller number because you increase from the small, and then you multiply your answer times 100. So I'm going to give you an example. Let's say a bike costs $80 to make and it sells for 120. Right? What's the percent increase? So it's $120, and I subtract the $80 because that's how much it costs to make it. And then I'm going to divide it by 80, and then I'll multiply that by 100. So 120 minus 80 is 40. Divided by 80 times 100. Well, I know that 40 divided by 80 is really 1/2. So I get 1/2 times 100, which is 50. So it's 50%. It's a 50% increase. What is 50% of 80? Well, 50% of 80 is 40, and 80 plus 40 is 120. So that's it. You take the big number, subtract the small number, and because we're trying to find the percent increase, you divide by the small number, you multiply by 100. You multiply the 100 to get the percent, right? Percent decrease. So let's say it's actually very, very similar. Take a look. This was big minus small. But because we're decreasing, you have to decrease from the big number. And because it's a percentage, you multiply by 100. So I weigh 150 pounds and I lost weight. I now weigh 145. So it's 150. Oh, what is my percent decrease? Minus 145 over 150 times 100. So I'm really going to get 150 minus 145, which is 5, over 150 times 100. And if I simplify this, I get 1 over 30 times 100, which gives me 100 divided by 30, which gives me 33. Wait a second. Is that right? Yeah, 100 divided by 30 gives me, and that's where I thought I had a problem. It's not 33, it's 3.3 repeating. It's a 3.3 repeating decrease. If I do 3% of 150, I'd get 4.5. So that makes sense. So 3.3% would probably give me the full 5 pounds. And that's it. I lost about 5%, 5 pounds. Not about 5 pounds. And like I said, 3% is 4.5. 3 1/3% would be 5. That's it. So now I'm going to do my percent error. And this one's a little bit different, but actually very much still the same. Oh, goodness me. What on earth? I did not want that. Let's see if this helps. Oh, yes, much better. Ooh, that was a scary moment here in math video world. So now I'm going to do percent error. And the percent error is how far away you are from your target. And it works like this. It's the actual value minus your value divided by the actual value. And this is actually the absolute value of that answer times 100. And that the absolute value just means the positive value of your answer. And it's not the actual technical definition, but for this lesson it'll work. So let's say I thought my let's make up. All right, I'm gonna say when I first met my wife, I thought she was 27 years old. And it happens that she was, well, I better be careful on this one. I'm going to say 30 years old. This may be the last video I make. So this was my value, my guess. This was the actual value, her actual age. So I take 30 minus 27, and I divide it by 30 because that's my actual. And like I said, and it's going to be times 100. So 30 minus 27 is 3. So what happens is I get 3 out of 30. Oops, 3 out of 30 times 100, which gives me 10%. If you multiply 3 out of 30 times 100, you're going to get 10%. So I was off by 10%. My percent error was 10%. Now watch this. What if I thought she was actually 24? All right, now I'm gonna erase my 20. Well, maybe I won't erase my 27. I'm gonna leave my 27 there. I'm gonna put in 24 years old. Well, take a look at this. Here's 24 on the number line. 24, 25, 20. I need a better number line. Let me erase this up here. 24, 25, 26, 27, 28, 29, and 30. So, no. Oh, goodness me. That's actually not what I want at all. So, let's say I thought she was here's my original guess. My original guess was 27. Here's her actual age. And so now I'm saying, well, what would have happened if I had guessed she was 33? All right, so now my value is 33, and the actual value is 30. So now I get 30 minus 33 over 30 times 100. And when I do that, I get negative 3 over 30. Well, here's what I want you to realize. It doesn't actually matter. And the reason why I use these funny lines is because it means the absolute value, which is a positive distance away from your answer, or from 0 times 100. And I still get 10%. And the reason why it doesn't matter is because I'm 10% under when I guess 27. And here I was 10% over when I guess 33. But I'm still wrong by 10%. So the value for percent error is always, 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 always positive. Because it doesn't matter if I'm over or under, I'm off by 10% either way. And that's it. I hope that made sense. It's actually a good lesson. And like I said, if I had worded this wrong, I might have made my last